Hey friends, MoNaCo here. Our first notes video in our 5th unit of study on moles and stoichiometry. We're going to be covering gram formula mass, which is a skill that you need to have in order to weigh chemical compounds in the lab someday. Our new background information is about Castle Learning Online. We've created this online website for you. Your castlelearning.com is the location. You click on the login. It's your RCSD dot your student number. And the first time you log in, you choose your own password. So my advice to you is to go get logged in. We've already created your assignments and your class lists for you. So get to it. We're going to have little assignments after each video or related to each skill in that castlelearning.com web suite. So what are we talking about today? We're talking about atoms. If we can't see them, how can we count how many we've got? Well, we answer this question by switching the how many to how much, because in a lab, you got to put things on a scale or to a ruler or in a graduated cylinder in order to measure them. So this gram formula mass relates the mass of a chemical compound to the elements and atoms and ratios of them that are in the chemical's formula. So that's what we're going to be working with there. We're going to be seeing how much a chemical formula would weigh if we put it on a scale using formula mass and gram formula mass. So in our introduction, we're going to even look at how we understand what this unit's about. We need to be able to find the mass of different compounds. So check out your periodic table and we're going to get started. Usually we already know this, but the atomic mass units, or AMU, are what we use to mass atoms because they're too small to actually put on a scale. The mass of the atom of oxygen would be 16, or AMU. That was 15.9994 that I rounded. Okay. Now AMU is the unit there. So we don't use grams as the units here because atoms are way too small. They'd be very bulky to use grams because if we use the grams to mass atoms, the mass of an oxygen atom would be this. 2.7 times 10 to the 23rd, negative 23rd grams. One atom of oxygen would be way too small of a number to deal with. So we came up with a different system. Using a periodic table, I'm going to find the mass of some following atoms just by taking the atomic mass and converting it into AMUs and rounding. So for magnesium, 24.305, that turns into 24 AMU. Okay. For aluminum, 26.98 rounds up to 27, and we put AMU on it. So all of these ones are up to you to find their atomic masses. Keep in mind, blanks lose credit on the final check. Monoatomic are elements that when you got one element that's stable enough to stand on its own. These are very rare type of situations. Things like gold and silver might be monoatomic, but other things like sodium and chlorine are not. We call them diatomic. Diatomic elements, or diatoms, are those atoms that always travel in pairs. We also called this Hofbrinkel. That's another way to remember them. There's only 7 of them, so it's the diatomic 7 plus the 7H club. Many ways to remember those diatomic elements, but that is not the entire point of the slide. The point of the slide is, what would the mass of a molecule of oxygen be? The 2 subscript here tells you that you have 2 of those oxygen atoms present. So if we have to figure out the mass of an oxygen molecule, we take the 2 times the 16 AMUs that we had for oxygen that we rounded and recorded off the periodic table, and we'd say 2 times 16 is 32 AMU. So that's how you find the mass of a molecule. You take the number of them and you multiply by the atomic masses added up. Now, formula mass and gram formula mass are almost identical. Almost. There's a subtle difference. Formula mass is the mass of the atom, molecule, or compound in atomic mass units, AMUs. Okay. Now, gram formula mass is the mass of 1 mole of an atom. That's a new counting tool that I'll be introducing to you in mini lessons in class. The gram formula mass of hydrogen is 1.00794. This is before we rounded it. The mass of 1 mole of H would be that, grams. So in the gram formula mass, GFM, all we're doing is we're talking about it in grams. So in formula mass, we did AMUs, But in gram formula mass, we're doing grams per mole. Per mole is the counting term that we're going to use in class. So the mole is this number, 6.02 times 10 to the 23rd units of a substance. It's like a really, really big dozen. We converted it down to 1 mole because it's easier to count by instead of, again, using a very large number, which makes calculations difficult. So the mole is a counting tool for chemistry that you're going to get familiar with. So if we're going to do formula mass, we have to do it in a certain way. I like to present it in a graphic manner. I like to do it this way, K2CO3, and you make a chart around it. Make a T-chart method, okay? Now what you're going to do here is you're going to do the number sign, the multiplication dot, times the AM. AM is going to mean something atomic mass. The equal sign, and then we are going to fill it out. And down in the bottom right corner, we're going to have the total when we're done. So on the left side on the brackets here, I'm going to put a K, C, and O, because those are the 3 elements that we have in this particular compound. K, we look for the number. How many Ks do we have? We got 2. How many carbons we got? We got 1. How many oxygens we got? We have 3. So we multiply, multiply, multiply. And this is where you take out your periodic table, and you multiply that number of the atoms in the formula by its atomic mass. For K, 39.09, we're going to round that to 39. Carbons, 12.011, we'll round that to 12. Oxygen, 15.9994, we'll round that to 16. So you're going to multiply these across. 2 times 39 is 2 short of 80, so 78. 1 times 12 is 12. And 16 times 3 is 48. Now the last little bit is you got to add them all up. So we add together 78, 12, and 48, 50, 60. 60 plus 78, 138. And the last bit, we put the gram. Oh, sorry, this is formula mass. So we're going to do AMU. Okay. So we'll do the formula mass of K2SO3. So we set up a chart. We counted the number of the elements that we have. We multiplied by the atomic mass, and we took the total to be the formula mass. In the scenario of this next one, we got 5 H2Os involved. So the same idea comes out here, but you set it up like this. CuSO4 dot 5 H2O. Number times atomic mass equals. Well, we got copper, we got sulfur, oxygen, and H2O. You'll find the number here to be quite easy. 1 copper, 1 sulfur, 4 oxygen, and we have 5 H2Os. Okay, now the atomic mass of copper, off the periodic table, 64 we'll call it. Sulfur's 32 we'll call it. Oxygen, again, 16. And 5 H2O. Well, if O is 16 and H is 1, then H2O itself is 18. So from this point, you're going to do the multiplication across, and then you're going to add up and get your total down here to figure out your answer there. That's kind of on you to do. That one's technically called a hydrate here. So we're going to practice these in class, but at this point, you should be able to figure out gram formula mass for most compounds out there using that T-chart method I just showed you on the previous page. In your practice packet, there's 2 pages of this type of material, 1 graphic, 1 word problem, and there's also a Castle learning assignment, about 5 multiple choice questions that we've created for you that you should also be able to do now. So thanks for watching our first video in the new unit.